how can we incorporate high performance concrete in material properties?
Okay, so what is there? You need to have some mechanical properties like Young's modulus, Poisson's ratio, mainly, and ultimate. You can say the compressive strength, tensile strength. If those properties are there, then you can tell the software that whatever I'm giving is high performance because software doesn't know anything. So only thing is the values matters there. So high performance concrete will have more compressive strength capacity. So only you need to have the experimental values. Otherwise, you take from the literature survey and you can put it.
Uh, can I add workability?
You're telling about slump, right?
Yes, yes, slump.
Uh, slump, I think slump can be added. Yeah, one more thing, slump cannot be added here, but water content, moisture content, I think you have to check that uh, because slump will not be added here actually. I've not seen anywhere for adding slump because slump is nothing but you have to add it is a unit, it's just a length or mm. So that if you add, no, you'll not get that result here. So actually, do you need slump actually?
Because other properties are similar to normal concrete, maybe. Um, uh, I think there is something special with the high performance concrete.
Yeah, yeah.
Uh,
Yeah, you're right, but
Flowability is the main specialty.
okay, but yeah, you can directly add it in the materials section. But I have to check like slump. I have not heard anywhere like directly that there's no property or slump you can add in the answers. But one thing is sure, like you can add the density and other things you can show. But why do you require that slump specifically? Like you want to say that the software should recognize your slump value?
No, sir. There are unique properties for high performance concrete. That's why I asked.
Yeah, you're correct. But I think you
Sir,
can't. Huh.
if I add 1% of steel fibers in concrete, how can I add in material properties?
So steel properties.
Steel fibers, small fibers are adding with the concrete. 1% of steel fibers are adding.
Yeah,
Uh,
in the con.
1% of the total concrete.
Okay. So when you want to add that steel fibers, one thing is you have to get the steel fiber. The uh, In the steel fiber section, like when you get the steel fiber from the market or from wherever it is, so
Uh,
they will mention you, they will give you some value or some properties will be mentioned. So have you seen those properties in that whatever material you have brought?
no, sir, but I will ask. It is
No.
there in our lab. I will ask it.
So if you ask them, they will give some properties, or if the lab instructor doesn't know, you can just go and ask, see the material in which it come. So there you will find the Young's modulus and other things. So if you do that, if you get that, no, then we can combine it here.
How can combine with the concrete?
Abhishek, can I just, I'm I'm not really sure. I'm just asking. Abhishek, is it audible?
Yeah, 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 ma'am.
Yeah, yeah. I was just thinking like the if we can give the constitutive relationship, then it will ideally capture all these. No, if there is some way we can just like in a DP model or something, if you can if there is a way to input the constitutive relations, then this must be able to capture the entire scheme, I think. Uh, uh, do we have any option for that?
Yeah, ma'am, you're right. But relation-wise, we can give that so that software will recognize. But she wants that same material what she is using to be recognized by the software. So then specifically, you need some properties of that material, right? So that what I feel.
Yeah, that's what. If Young's models and related things, if we are getting also, can be like, I mean, for such a discrete things, can we input those values and the combined effect can we get like that?
Yeah, we can do it, ma'am.
Okay, okay, okay. I was, yeah, Juliana, you continue. I just asked in between. That's all.
Okay, ma'am. Uh, uh,
So what I told you is you just can get the properties. You can ask your the source from where you have got it. So when you do that, no, you can create a combined material property for that material so that it will act as a uh, one material. There, as Madam told, some relation you can write. But if what will the software do? The software will understand the relation, but according specific to your material, if you want, no, then you need that properties only. Otherwise, the results will not match.
Sir, can I
Uh,
test the whole material that is concrete with the steel fibers? The combined strength, elasticity, all are to be incorporated, right?
yeah, you can test, no?
Okay, okay.
So, see, one thing, what I can give you a suggestion is in Ansys, the main problem is the properties, material properties, and the interaction relation. If correctly defined, then it will take. Otherwise, most of the cases, the software will assume some other material, and your material will be different, and you will not get the expected outcome. So if you're doing, have you done some experimental investigation, or you're going to do, are you doing only analytical thing?
Both experimental and analytical.
So experiment is done.
Yes, sir.
Yeah, then I think you will get the properties from there. Then you can just put the values in answers.
Okay, sir.
Okay, fine.
Kartika, are you ready with the screen and all that?
Yes, ma'am.
Yeah, Abhishek,
Yeah,
should we ask the others to present or?
yeah. Let them present.
Sir, hope you can see the screen.
Yeah.
This is the model made for the flexure test.
Okay.
So here in the connection, there were no automatic connection developed for the reinforcement mesh and the solid. There is a mesh layer that I can show. So there is a reinforcement in the form of a mesh.
Okay. So I just show me the connection part there. Connections.
So these are the connection.
Yeah. So just click on that.
So it's the automatic connection that generated.
Okay. Yeah, it's correct now. But one thing you're not able to see is I'm not able to see the connections inside that concrete element. The mesh is not, there's no mesh visible, right? Mesh is not
Yes,
connected to concrete, I feel so.
connected to the concrete. Yeah, that's the
Yeah.
problem. So I was not able to give a connection between this concrete and the mesh.
So now, whatever the software has already done it automatically. Whatever seeing in the screen, no, it is nothing but the software connection. But here, actually, the mesh is not recognized by the software. So what you have to do is you have to define it manually again. So what you can do,
Uh, Define another connection.
yeah, define another connection. Just remember what are your contacts and target, contact and target for this section. Overall, it is correct, but only make sure that the reinforcement is connected to concrete. You just make that change and then and run the analysis.
Okay. In the solid, here can I select including the mesh? So how will I select? I don't get it properly.
So what you have to do first, you have taken a frictionless. Just take the second one. So
Okay.
so it's not like
The
now,
target body.
yeah. Just go into that. And one more thing you just need to do is, yeah, you just select the concrete part as a what you can say contact body, and then the target should be your reinforcement. Sorry, the reinforcement is in
Target
contact.
is
Sorry, I told
okay.
reverse. Target is your concrete body,
Mm.
and the contact will be your reinforcement. That thing you have to define.
Okay, okay.
So what you do, whatever I'm saying, is just follow that. First, you go to, you already taken contact. In that, you have taken frictionless multiple to solid
Mm.
2. So select that. Yeah, yeah, correct. Now you have to select all the mesh.
Getting selected.
It has selected only 4 bodies.
Mm.
Yeah, yeah, there was a plus sign actually. Once again, you do that
Again,
same
showing
operation.
four bodies.
Ah,
Okay.
uh, yeah, just wait. Don't hurry.
Sorry.
Yeah, wait. First, after dragging, you don't do anything. Just leave it there.
Okay.
Ah, there you select that at what contact.
But but again, it's showing four bodies. So it's already hidden, even though showing.
Actually, why it is showing? Why there is a cross mark in the mesh part here? Like, just select the mesh here in the model part. Yeah. So these are all line bodies, sir.
Yes.
And what is the mesh reinforcement assignment is mesh reinforcement. Okay. But why it's not?
Yeah.
Hmm. Okay. Just go back. Okay. Just try to work out in that way. Meanwhile, we'll see some other. Just what I told, no?
Okay, I'll try.
Yeah. Just try that. Okay.
Okay, sir. So in explicit, I'm doing repeated impact in the same model in explicit. So where I can give it as a reinforcement. So that this issue is not in explicit.
Yeah. This is not in explicit. It is a static structural.
Yeah.
Yeah. You can give as a reinforcement. Better you give as a reinforcement only. Otherwise, it will become frictionless. Means the context will not be defined properly. But only thing is in frictionless part, the solution will be faster. But in reinforcement, some time it will take because it has to analyze that
Okay.
context, right? Just select the reinforcement part from the context part. Let us see.
In explicit or there?
No. You have to select frictionless only. Just select the frictionless.
Okay.
Select it.
So, so creating a new contact. So okay.
There is a type there in definition below. Just come down. In definition part, type frictionless. You change it to reinforcement.
Okay, sir. That I understood. Yeah, here. Frictionless. There is no reinforcement option in
Actually, there is a buffer here. Like what all you are seeing there?
bond non-separation, frictionless, rough and frictional.
So if you are doing frictional, then it will ask the no value.
Yeah.
Okay. Just leave that because let it be frictionless only. But you define the contacts. Whatever I am telling you,
Okay.
if you define it that way, yeah, the work will be done.
Okay, sir.
Just try that and run the analysis. Let's see. Meanwhile.
Okay, thank you, sir.
Sir, is visible?
Yeah.
Sir, this is how I just doing the detonation part. Uh, Here I just given that initial conditions. No, I just not giving any velocity here, but the detonation point with the detonation time of 1 into 10 raised to -3 second.
Okay.
So what does it mean that the detonation time means? I I don't know how to give this detonation time. I just randomly given it as a this value. So,
Yeah.
what it means, I don't know that.
Okay. Actually, the detonation point is not, the time what you're going to give that time detonation time. So actually, detonation time is the time interval for the blast. Okay. So always the time interval should be less itself. So only like don't know. You can take you are taking less than 0. Yes or no? you're taking 0 point something, 0.00.
001.
Yeah, yeah.
Okay.
So it is very specific to your project. So in the literature survey, I think you have gone through some literature survey.
Nice.
So there they have taken, they might have taken this value because for a small interval of time, we are going to check the impact of that blasting. If the blasting
Okay.
is, so once very small example, if I want to give you, suppose if you are burning crackers, you want, what you want when you just ignite the cracker, you want it to blast acid after some interval of time. Yes or no?
Nice.
There will be some expectation. But if it blasts very late, suppose you light it now and it will take some 10 minutes to blast, then you'll not get the correct answer there. You'll not be,
Okay. Okay,
and
sir.
blast will not happen like that. And nobody
Okay.
will do intentional blast will not be in that way. So what you will do, you have to take, you're taking that the time interval very less. But
Yeah.
if you increase the time interval, no, then what will happen? The impact of the blasting will reduce. Even you
Okay.
can see that the stresses, whatever you get there after the impact, those will also will be less when you compare to what you are giving now.
Okay, sir. So, uh,
Yeah,
in
fine.
the solution part, just given us a total deformation like this, uh, how can I get this residual capacity after the blasting?
Uh, can you repeat the question once again?
Just do it as the solution. This is the total deformation shown in the figure
Okay,
here.
fine.
But how can I get the residual capacity? That means the capacity of the column after the blasting. Means residual capacity of the column. Can I get it from anywhere? Was it from the worksheet or any solution
Uh,
part? Can I?
See, one more thing I just want to tell you is, so what is actually you have not seen any principal stresses. Just go and select the principal stress. You need the principal stress for getting the exact capacity of the column. You need principal stress. Stresses are just maximum principal.
Vaccines.
Yeah,
Okay. All
just
bodies. So I
uh,
want to hide the solid part or all bodies.
no.
Select solid. Okay.
Already everything is done. No, just solve the part.
Okay. Okay.
Okay, can you run the animation, please? And just take that graph so that expand that graph a little bit.
Or just print, I think.
Don't cancel it, otherwise it will go. Just try to fit that. Huh? Yeah. Yeah, yeah. Now you run. Okay, fine. One more thing here in the left side here, in the outline details, just go to the bottom. Just scroll down to the bottom here. Yeah, there. So whatever minimum over time. So whatever you're going to see that the value, whatever it is given here, maximum value is 1067.6 megapascal.
Yeah.
Okay. So that is one thing. And one more thing is, you can say that is the capacity, but you can't stop your analysis here. You have to run some few more trials. Like you have to go a little bit. You have to go it very. You can say with an increment of say whatever the time interval you have given. No, according to that, if you reduce the number of cases if you take, no, then you will understand at exactly what location the maximum capacity is there. Otherwise, the software, whatever you give the value, it will give some results. And one more thing, just the same column, have you designed this column or randomly you have taken the size?
I designed this columns.
Okay, so when you design that column, then you'll be having the uh, what you can say, the combined effect. How much you have got? What is the moment and response?
So moment, this is only the in case of blasting only. Moment is in solution part. Do we say it in solution part? Momentum means
So what load you have applied? You have not applied any load there in
it's a
the.
blast load, sir. Blast loading. It's only with the axial load, sir. I'm not applying any other loads here. Only the blasting is occurring along with this axial load.
Oh, okay, fine. So you're asking me, so to when to stop or what is the maximum capacity that it can
Capacity,
hold?
how can I get it from the software? So I just this damage all. I just inserted the damage all properties.
Yeah, okay. So I think you have to. One more thing I wanted to ask in concrete, no, what material, what properties, normal ANSYS concrete you have
No
taken, or you
explicit material, man, sir.
explicit you have taken, right?
Okay. So this is a damage.
Yeah, yeah. Just go, just you can zoom through it. Just remove this graph, like not be correctly visible. Just fit it inside. Okay, fine. Okay. One question just I can ask you is like, do you still feel the column will withstand after this simulation? Like you know
Yes.
that still have to go start from the beginning, because in explicit dynamic you can't. What you can do is you can start it from beginning itself. Little bit you have taken one load and you can't conclude that whatever you have done, no, you can't conclude that this one is failed. Now it is already failed because already the particles are coming out, and that, but you want the ultimate capacity, right?
Yes. Yes.
So for that you have to do multiple trials. Just you can apply whatever the detonation you have chosen, no, let keep that constant. Okay,
So
what you do?
detonation, I'm just only given the detonation distance 600 and detonation time
Yeah, keep
and
that
weight of
constant.
the glass material only. And
What you do, you keep the location constant, let it be there, but
okay.
time factor you go on reducing.
That time factor in sense detonation time, sir.
Yeah, detonation time
Okay.
you go on reducing, so that time you will get the understanding at what time it has failed. Okay,
So
and one
fail
more.
in the sense is I am only getting the damage behavior. So
Just
here,
one second. Let me complete. Okay, what I'm telling, when you go with number of trials, suppose let's say uh,
no,
give, just for a vague discussion, let's say for 0.1 second,
no.
let us say my column is still intact with no damage.
Okay, sir.
Means minimal, very minimal damage. There will be damage because for blast there will be damage. Very minimal
Okay.
damage is there. Now you will get the maximum principal stress. Why you have to take only principal stress is because the material is concrete. So for concrete and steel, if it is combined, usually mechanical people, they usually go through the equivalent stresses. They conclude by equivalent stresses, but we can't conclude by equivalent stresses. We have to go for the maximum principal stress. And
Okay.
one more thing,
Maximum principal stress, sir.
yeah, just one second,
Okay.
let me complete.
Okay. Okay.
So you have stress now.
Okay.
You have the stress value, and now you're also having the area of cross section, or you can get the area of the material, whatever, because you know the geometric size of that column.
Yes, sir.
Okay, fine.
Okay, sir. Okay, sir.
Okay, and one more thing, which concrete, what type of concrete you are telling that you have used explicit material. So there the in material property, explicit material property, the you have to check the maximum compressive strength property will be there. That how much it is you have to check. If
Okay.
it is
Okay.
increasing, whatever the property there it is there, if it is increasing that value, then you can conclude that there is a failure.
Sir, how can I check this compressive strength of this particular concrete?
This you have to check in the material part. Just go to the material section, which material you have assigned. 35 MPa, right?
Okay.
Okay. There is a concrete strength here. Just go below. Now compressive strength 35 MPa. That is there.
Okay.
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 Fracture strength, elastic strength, just go below. So 35 MPa is the material which you are used, right?
Yes, sir.
Uh, but exactly if you want at what load it will start failing is that one more thing, you have not applied load also. Only for the blast you are concluding, right?
Yes, sir.
Okay, from blast if you are concluding, then you have to do the more number of trials, I guess, because you can't say at one location, because 35 MPa already you have got more load now there. So 35 is very less. And one more thing you should remember is you are having the combined effect of concrete and
Steve.
steel reinforcement, right?
Yes, sir.
Uh, Steel which you have used,
Sir, 4340. Explicit material 4340 steel.
4340, right?
Yes.
Okay, just one second. Uh, so actually, what I mean to say is whenever there is one rule actually. See here, actually when the maximum principal stress of the concrete or whatever material is there, so if it is exceeded by the already when the stresses in the column or concrete, if it exceeds the maximum principal stress, then you will definitely observe the you can see the failure, right? So if it is 35 megapascal, so your concrete has failed. So already it has failed for very small load also. Whatever you are
Oh,
doing analysis
oh,
now, it is
okay.
more. The intensity of that blast is very high. You are not getting that initial where it will start moving. Yes or
Okay.
no?
Oh,
So for
yes.
that you need to do number of trials.
Okay.
So just in your just remember that whenever the the compressive strength is 35 MPa, whenever the concrete material, if it crosses that, then there will be definitely there will be crack growth. Cracks, there will be cracks, and that is the beginning of the failure point. Yeah.
Okay.
So for that, to determine that, one thing is you have to reduce the strength of the TNT. One thing you can do that. Otherwise, keep your
Okay.
TNT, reduce the time, detonation time.
Okay. So,
Reduce in the sense you have to increase the time so that the
okay.
blast will happen very slowly.
Suddenly. Okay.
Okay. Now it is
Um,
very suddenly it is happening in a fraction of a second.
okay. Okay.
So
Okay.
in that way you can just come to a conclusion.
So, TNT, sorry, in the case of TNT, there are
Okay.
some parameters here. I don't know what is it is. Can you? Uh,
So these are some parameters which they have considered while in the literature survey, the answers packages, they will have uh, referred some material and then put that material in general. So that reference, if you want, no, you'll get it in the material. In which paper they have referred for this material. This you will get in the when you're selecting the material. There will be in the cross reference, in the reference part there, you will know the paper from which they have taken or the experiment which has these values. So
okay.
that is the thing. So if you go there, know what parameter they have considered, you'll understand.
Okay. So we can only change the parameters TNT, that density and weight, right?
Yeah, that you can change, but
So
you.
weight can be changed by only by making the model weight,
So
or it
what you
is.
do, yeah, weight. You can if you change the density, automatically weight also will get reduced.
Okay. Okay. Okay.
Don't do both.
Okay. Sir, I'm also doing some impact and blast, combined effect of this impact and blasting. Uh, so that in that case, I just applied the initial conditions as with providing some velocities.
Okay.
That is here. Here's a velocity of 5 mm per second
Okay.
and input type velocity along with this detonation. That means not only the blast, it is
Impact also.
simulate impact also. So
Uh,
is it
so this is very harsh condition, no?
I
Impact and blast.
with velocity? So yeah.
Okay. I think yeah. So for velocity, at least you have to put some value. That is fine. But both
Okay.
impact and blast, I think that impact is just sorry, the TNT is just colliding with the column, and suddenly there's a blast. So what
Sir,
you
I
want
think
specifically? What you want to
sir,
ask there?
I think the impact is not taken consider while the analysis because the blast is more severe here in this case. So the effect of this impact is not um, properly get it in the solution.
So one
Um,
thing what you do is just click on the solution part. I'll just tell you. Uh, so now what you do, just wait for that graph to come. Where that graph went? Animation. Just go for the graphics animation part. Yeah, where is that animation?
um, so-
Okay. Just Now what you do, just increase the time. The time lock, it is for 2 seconds, right? Just,
Yes, sir.
yeah, just increase the timing. Let us, no, don't do that. There only you can do.
Yes, sir.
In the graph value, there 2 seconds auto, it is there, no?
Okay, okay. Okay, sir.
Drop down.
10 seconds.
Yeah, just go for 10 seconds. Let's see.
Okay.
Just, I think you can see it very clearly in your PC. Just you have to guide us now. So whether there is an impact, and just go for an isometric view. I'm not able to see whether what's happening there. Other view,
Isometric view, sir.
yeah. Just make sure. I want to see the back part here. Rotate it. Yeah, yeah, just in that way. One more thing I just wanted to ask, like whether you have put the reinforcement for this,
What, sir?
whether there is a rebar for the column.
Yes, sir.
Uh, what you do, you hide the concrete and you hide the concrete part and just check the results for only line bodies. Yeah. Then just go for the solution. So one thing I just got to know is here one thing. Now you want the ultimate capacity of that column for the blast. So what you do
Yes, sir.
for concrete 35 MPa material, after 35 it will start developing cracks. Okay, because for blast it will start. And
Okay.
one more thing is for the steel. Okay, for the steel you have to check the ultimate compressive strength, or you can tensile strength and compressive strength. You can check there. So whether the value, whatever maximum you have selected, I think you have selected total deformation.
Yes,
Just
sir.
select the stress solution part.
Principal strength.
Yeah,
Principal
select
stress.
the prince. No, that is
Principal stress.
shear.
Okay.
No, don't do anything. Only those. Okay, just go.
Okay.
Maximum principal stress. I don't know. The means your reinforcement is not affected at all, like because it is not showing any stress. No.
Yes.
Uh,
Can I select the whole body, including the solid bodies?
yeah, just no. You'll not be able to see that. Means I think you have selected. Uh, have you selected any specific material, or just you have simply run the analysis or reinforcement?
Specific material means
Now what you do? You just select the bar that has bent here. The bent bar. You just select that as a solid body, and then check the results of that bar.
so three of them having the bending, sir.
whichever one is having maximum, you can select that one.
Okay.
Select the solution part. You'll not be able to get that. Now you select.
Okay. That's it.
Select that, and now go for the solution. No, don't do anything.
Okay.
Select that. Okay, then go for solution here. Right click on solution and just check the max equivalent stress. Yeah, one masses. Now just ask it to solve.
Yes.
Array. Then I think there is no stress to the reinforcement. Then how it is able to just move? I'm not understanding whether the contact is correctly defined or no, because all the load is taken by the concrete itself. I
But sir,
think there is I think there is some issue in the contact region, because here, how can you guess, like you are saying that I have what your situation represents is, you are saying that I have got a fracture, but my bone is not affected. So how can it is possible? It is not possible, no?
yes, yeah. Sir, I
So
just in the connection part, I just given the body interaction to as a reinforcement type here. So
no, you're not given. Just check once again.
it's reinforcement, sir.
That is correct. And one more one. Second one is what? What is the second one?
Sections.
Just select the show all bodies. Uh, I'm not able to see where it is applicable. Okay, chalo, leave that. Just go select the contact region. First one. First contact region. What is in contact with what?
Sir, actually fixed base is there in the bottom portion, the blue color.
Okay, fine.
So and
That
delete it.
that is one phase and other phase. Fine. Next one, second one.
Lateral restraints, this one.
Okay, fine.
The last 4 lateral restraints are there, so that's where the four
But
conduits.
where is the connection of the reinforcement to the concrete? I'm just telling that. Somebody asked me, I think previously, I told them.
It's yes, I think this will be captured in this body interaction one. Um,
So you have to give the reinforcement and concrete connection. So now what's happening? The concrete is playing. Concrete is dominating, and reinforcement is not participating only. So then will not be
okay.
correct result, right? So what you do, my suggestion is, you have to make your reinforcement. You select all the rebars, make them as a contact surface, and the target one is make that concrete as a target material, and then you apply the same blast. That time you will see the stress developability less.
Okay. Sir, contact body is a concrete and the target body is
No, no, no,
reinforcement, right?
no, no,
No.
no. Reverse.
Okay, sir. Okay.
Yeah, anyone? I think Has
Abhishek.
yeah,
Is
ma'am.
there
I
anybody?
think
Ah,
this one Anaga has asked the question, and
yeah. Yes.
I think this one I'm not able to get the full name here.
Juhena.
No, no, I think she has asked the question. One
Yeah.
minute.
Kar
Let me see the participants list here.
Sir.
Harita,
Aneka had a
Harita.
question.
I
Miss, I
think
have a doubt.
I think
Sir,
Harita has not asked any question.
ask. Sir,
Okay.
I have a doubt.
Yeah, yeah. Tell me.
Sir, I am doing the project.